Good morning all. I have some new printed circuit boards from JLPCB. So without further ado, let's open the box and take a look inside. And they are these. And they're mini jack daughter boards. So let's get one of these open. Which one shall I open first? Let's do this one. No, let's do this one. I've done these in green. I'm doing all the Vocoder boards in green, even though now you can have any colour you like at no additional cost. So I could have done these in blue, red, yellow, black, white, actually matte black. I've sent a board off for production in matte black, so we'll have a look at that soon. So these have been panelized using the panel by JLPCB option, and I'll show you that in a moment. And I've managed to fit 25 of these little boards, they're very small, onto one panel. So since I have 10 panels, I've got 250 PCBs. How many of these printed circuit boards do I actually need for the Vocoder project? I think it's 2. If you'd like to know more about PC panelization using JLPCB service, you can come to this page, and I'll put a link to this page in the description. PCB panelization. Now, the only thing that I've been caught out on so far is the minimum size requirement for a panel to be V-scored, and it is 70 by 70 millimeters. Now, if you want to stay within the 100 by 100 millimeter size to get the best price on your PCBs, then you really need to have an overall panel size not less than 70 by 70 and not more than 100 by 100. Although it does say right at the bottom, the maximum panel size with 1.6 millimeter board, which is what I generally use, is actually 300 by 300 millimeters, so that's about 1 foot square. Right, let's break off the little border piece. So these have been V-scored. So they cut with a little grinding wheel or grinding disc a line through between the boards, and that puts a little V-shaped groove in the fiberglass. I'll get a magnifying glass. So I think you can see there on the ends of the fiberglass PCB how they score these V-shaped lines into the ends of the printed circuit board, and that of course makes it much easier to snap them. I was using this pair of pliers to snap off this little edge piece, and now I can just snap my PCBs into the individual boards that I need for my project. Up to now, I've used the JLPCB, their own panelizing service. So if we start on the home page and click calculate. So this is the JLPCB quote page or order page. And here's where you add your Gerber file. You'll also come here if you come straight out of EasyEDA, and it will upload your Gerber automatically. Now let's say we've got a very small PCB, which is say 15 millimeters by say 20 millimeters. All I need to do here is hit panel by JLPCB. Yes, let's scroll down a bit. And I need to key in a quantity of 15 millimeters, which takes me over 70. So let's try 4. That gives me 60, so that's not quite enough. Let's try 5. And that gives me 75. So that's ample. 4 20s will give me 80. So that tells me that I've got 15 5s plus 10 millimeter for the 2 5 millimeter edge rails. That's 85. That's above 70 millimeters and less than 100. And the other dimension is 80 millimeters. So that's perfect. If I hover over this, for example, you can see examples of the panelizing with and without the edge rails. You can switch the edge rails on and off here. So what are these little boards for? Well, the PCB tracks don't give much away. They're very symmetrical. But you can see that on the top here I've got a silkscreen outline of a dual inline package. Now that's not an IC. It's actually going to be an 8-pin connector down onto another board. So this is a daughter board. And on the other side, I've got 2 mini jack sockets. Back to my printed circuit board, and I'm going to fit the 2 jack sockets that go on here. Let's zoom in for this. So the components that are going on the top side, I think it's the top side, oh, I don't know, can't remember which is which now, are these little mini jack sockets which I got from Alice on eBay. There are lots of different types of these, so if you do a PCB design for one type, you've got to make sure you can keep buying that type, otherwise you're going to come unstuck. So does this fit on here? And the spacings between 2 of these sets of pins is different from the other 2, so this had to be measured quite precisely. Oh, it goes through. That's quite a tight fit. I could have made those holes a little bit bigger, but actually a tight fit probably is advantageous in some ways. Now I can't push that down, and that's because, I don't know whether you can see, but there are a couple of little plastic pips on the underside of this, and I didn't make provision for those on the board because they foul with the connector, which is going to take these connections on these sockets down onto the PCB below. Now I could have offset this and made a much larger board, but I specifically wanted to give myself the challenge of having the 2 rows of connecting pins that go down onto the board below directly under the sockets, just to make it difficult, really. So one of the first things I'm going to have to do is cut off these little pips, and that shouldn't be too difficult to do with this knife. Try to not have my finger on the other side when I do this. Oh, that's one gone. Let's take off the second one, finger out of the way. And there it is, those 2 pips have been removed. So this will now sit flat on the board, and I will put these 2 down on this board, even though they're going to have to come back out again to solder the dual inline pin array. But let's put these in just to see whether they fit and that they sit flush to the board. Oh, that fits rather nicely. Let's do the second one. Yes, I'm very happy with that. Let's have a close-up look at that in its board. So the pins are slightly bent, I think, in an effort to hold the sockets in the board, but these fit very tightly in the holes, so they absolutely in no way are going to fall out. And then you can see the tracks that I've put on there to connect onto the dual inline pin arrays. So let's have a look at how that's going to work. It's going to be 2 sets of 4 from here. So let's break off a set of 4 and a set of 4, and then those are going to sit on the underside like so. Now of course at the moment they don't push fully in. Let's have a closer look at that, because they're actually extending. Well, I need to push these black plastic holders down so that they're flush with the board, and that means that the metal pins on the top side are flush with the board, because of course the sockets are flush with the board. So let's do that now. I can do that with a pair of pliers. I'll just put that in there. Oh, that's stiffer than I thought it'd be. Maybe I'll use a screwdriver. Let's try and push these plastic pieces. Oh no, it's not working because it's just pushing my sockets out. Okay, let's do it down on here. Press down on these black plastic pieces. They do slide, but they are quite tight. Actually, maybe the pliers would be better here. Right, I think that's done it. Let's have another look through the magnifying glass. So that's what I want. I want the 2 sockets flush to the board one side, and oh, it's all collapsing. The 2 rows of pins flush to the board on the other. I think you get what I'm trying to do here. Now for soldering, I'm going to have to take these sockets back out. That's slightly tricky because they are quite tight. Let me do that off camera. just in case there's an incident. So back to the bare board. These have now been pushed down, so we've only got, well, it'll be 1.6 millimeters of pin exposed, won't it, so that it fits through the board, but it's flush on the top. Fit those two in, and I think it's time to solder those. Now I might put this into a breadboard just to hold it all square while I solder from the top, and I'm going to have to be careful to try not to produce mounds of solder. So actually I might use that very fine solder I got on eBay. Yeah, let's try that. Right, ready to start soldering. I better turn the iron on. Okay, so I'm going to use this cuckoo solder. It's KOOCU. Yeah, cuckoo solder. So this is 0.3 millimeters. I haven't really used solder this thin before. But it'd be an interesting challenge. Right, that's up to temperature. Let's give this a go. I'll try and bring the camera a little bit closer, although I've got to leave enough space for me to be able to see what I'm doing. I drenched the bottom sponge, so I'll put one on top so that I can, it's not so wet. And I'm just going to push down on the board. Oh, that melts it. Okay, perhaps I won't do that. And I need to just lay some solder in there, but in such a way that it doesn't mound up. Oh, it's mounded up. So that's not working. Now I'm just wondering whether that's because actually air can't get through on the other side because the plastic is held over the hole. But it doesn't seem to be flowing down there terribly well. Oh, that has. Oh, I don't think this solder's any good. I think it's as bad as the Jinhu stuff I had. Let's go back to my real solder. I'm also going to flood this with liquid flux. Yeah, there's flux in there from this flux pen. Yeah, this is proving difficult with any solder actually to get solder to flow down the gap without mounding up on the top. Oh, maybe it's slightly easier. Yeah, to get it to flow down the hole and not mound up on the top is proving tricky. So it looks like my sockets are probably going to sit a little bit high because of these mounds. I suppose I could actually solder suck these after I've soldered them. That one actually worked very well. So much so it doesn't look quite right. So I've just built a mound where there wasn't one. Yeah, could I solder suck these? Because there's no way you can suck all the solder out of a hole that has a tightly fitted pin in it. So would that work to simply remove the surface solder? I think it's worth a go. Yeah, I might try that. So a little shot here of me sucking the solder, and yes, that's resulting in what I want, which is absolutely no flush solder. It looks like I've sucked the solder away, but there's no way you could suck all the solder out of the entire length of the hole. This is a bit of a palaver, but if I want the socket, oh yeah, where the Chinese solder was, it really hasn't worked at all well. There's something in that solder which just isn't quite right, and I don't know what it is. A close-up look at this, and you can see that 6 of the holes look quite nice. The 2 nearest holes on the outside look a bit horrible, and those were the ones that I did with the cuckoo solder. So yes, I'm thinking my solder probably is better. Right, next step is to put the 2 mini jack, these are stereo mini jacks, so they've got 3 connector points. These ones have a strip that runs over the top and then comes down on 2 pins, so those 2 pins have the same function, but for some reason they've cut this middle pin off. So I remember on the Alice eBay listing, these were described as 5 pin, so quite where they've cut that middle one off, I don't know, but I put 6 pins on my board because it's all symmetrical underneath, didn't really matter. but 5 pins it is. Okay, so let's poke those in, and their pins sit either side of my dual inline pin arrays, which is rather good. That's how I wanted this to be, because I wanted it to be super duper compact. So is that going to sit flat? No, not quite. There's a tiny amount of rocking of these sockets because of the tiny protrusions of the solder mounds from these pins underneath the sockets. But yeah, essentially that's what I wanted. 2 sockets compactly mounted above an 8-pin pin array. Yeah, I'm quite pleased with that. So let's get soldering these. Some of these I've got to solder between these 2 rows of pins, which will be slightly tricky, but not impossible. So the final bit of soldering is just to get these sockets soldered onto the board. That's relatively easy. That one there is the missing pin that they've cut off for whatever reasons. Let's do the outside ones first. Do those on camera and then struggle with those inside ones off camera, because I think I'm just going to have to get in much closer to be able to see what I'm doing, because to stay out of shot I'm quite some distance away from the workpiece. I think that's it. So soldering iron off, press both buttons. That's good. Right, let's have a close-up look at this through the magnifying glass. And there it is, pin arrays to the bottom and 2 stereo jack sockets on the top. Now this module has a couple of different uses. One of those is that it's breadboard friendly, so that it means you can plug, if you can get it into the breadboard, you can plug this module into a breadboard and connect audio mini jacks, or whatever you're using stereo mini jacks for, to your breadboard circuitry. So that's the first use of it. But the other one, of course, is that it goes onto my Vocoder boards, which use these daughter boards as a sort of multiple choice for interconnects. Let's have a look at the input amplifier. So here's my input amplifier printed circuit board attached to the front panel. I think I'm going to detach it from the front panel in order to show, well actually no, I don't need to, because in this drawer I've got lots more of these input amplifier boards. So I won't take this off because it's a bit of a fiddle, because you've got to take the knobs off, undo the pot nuts and all this lot. I'll show how this daughter board, this one, fits onto here. So the idea is, by putting on my input amplifier board these dual inline 8-pin pads, you can have either a dual stereo mini jack on there, which would sit like that, or you could assemble the RCA daughter board. So you've got the RCA phono socket that clicks into there, and again you would solder on 2 4-pin header arrays. That could sit there. You do have to snip these pins down a bit because they're rather long. Or you could use the original mono, this one's a jack daughter, this is a full size 1/4 inch mono jack. That one could go in there as an alternative. Now don't get me wrong, the idea of this is not that you can just keep taking these out and putting new ones in. The idea is that you can make your choice, which connector type do I want, put it in here, solder it, and then it's as good as mounted directly down onto the main board, because those 8 pins have very high mechanical strength once they're all soldered. It just means that I don't have to think about which footprint to put on this board. I can actually make that decision later by selecting an appropriate daughter board to put on my main PCB. Now, just before I finish, I ought to open this other one, which came in at the same time. And this is very similar but subtly different, and I'll explain why. So this one I panelized 6 by 2 to get the same minimum 70 by 70 dimensions. Let's snap off these edge rails, break my boards and get down to one board, and there it is. And it's a quad version of this. This is the dual stereo mini jack daughter board, and this is the quad mini jack daughter boards. Let's put some, so you can see that there's a single 8-pin footprint there for the pin array, and they're all commoned up because the same signal is going to all 4 of these sockets. In fact, because these are stereo, it's going to all 8 of the signal lines. They're all commoned. I'll put some of these sockets in here and just have a quick look what it looks like. Once again, I'm cutting off, shot's not going to fly. Actually, I'm finding that these little bent over pins are kind of digging in to the through hole as this goes through. So I'm just wondering whether I might slightly straighten these with pliers before I push this into the board. That might help a bit. So on this one I've just put the 4 sockets in. I haven't put the pin arrays in these holes here yet, but you can see that it's a quad version, which means there are 8 signals coming in and all combining together. You couldn't actually have 8 signals plus ground on this 8-pin connector, but in this particular application all those signals are combined together because this is acting as the input of a mixer. 2 sockets on that module, 4 sockets on there. So those are my mini jack daughter boards. Wonderful. Cheerio.